All right, so today we're going to talk about piecewise functions. So a lot of times you have functions that can't be described with just one rule or one equation. And so you have to use a couple different rules or different equations. So they look like this. This is an example of a piecewise function. So you look up here, f of x equals, well, it's equal to 3 if x is less than negative 2. It's equal to x plus 2 if x is between negative 2 and 5. Or it's equal to 4x if x is greater than 5. So as you look at these different x values, depending what the x value is, you're going to use a different equation or a different rule. So let's go through and evaluate a couple of these, probably the easiest way. So let's start out, I have f of negative 8. So here's how these work. So I come up here, I'm going to plug in negative 8. I have to decide which of these three equations to use. These conditions over here tell us which one. So what I'm asking myself is negative 8 less than negative 2? Or is negative 8 between negative 2 and 5? Or is negative 8 greater than 5? Well, negative 8 is less than or equal to negative 2. So that means I'm going to use this equation right here. So if I plug negative 8 in, well, there's no x, so I don't even have to plug it in. It just always equals 3. There's my answer. Let's do this next one, f of negative 2. So again, I have to look at my conditions and decide which one or which rule or equation I'm going to use. Negative 2 is not less than negative 2, so it's not that one. Negative 2 says x is greater than between negative 2 and 5, but it has the equal sign, so it can equal negative 2 or equal 5. Well, it is negative 2, so this one does work right there. So I'm going to plug in that equation right there. So I plug negative 2 in for x. I get negative 2 plus 2. So it works out to be 0. Let's try f of 3. Hey, 3 is between negative 2 and 5. So I'm using this rule again. Plug the 3 in. 3 plus 2. So I get 5 for the answer. Okay, let's change this one. Instead of f of 5, let's do f of 7. All right, 7 is not less than negative 2. 7 is not between negative 2 and 5. 7 is greater than 5. So that's the one I'm looking at right there. So I'm going to go 4 times and plug 7 in for x. So f of 7 equals 28. So when you go to evaluate a function, piecewise function, you first have to look at each of the rules, each of the conditions, and decide which is the correct equation or rule to use. So first look at this part, right? They'll tell you which one to use, okay? And then once you have that, you plug your x value in. You got your answer. Hey, we're not going to graph this one. Instead, let's evaluate this next one, and then we'll also graph this one, so you can see what the graphs look like. So I want you to start with 1, 2, 3, and 4. See if you can evaluate those first on your own. So pause the video and try those. Then we'll come back and we'll talk about it together. All right, so f of 0. 0 is less than 1, so it fits that condition, so that's the equation I'm plugging it into. So it'd be 2 times 0 plus 1. 2 times 0, 0. 0 plus 1 is 1. F of negative 1. Let's see, negative 1 is less than 1, so we're using that same equation again. So 2 times negative 1 plus 1. That'd be negative 2 plus 1, which comes out to be negative 1. F of 3. 3 is, on this one, 3 is greater than or equal to 1. So we're going to use this equation over here. So we're going to get negative, plug the 3 in, negative 3 plus 3. That comes out to be 0. Okay, this is a tricky one. It says f of 1. So you have to decide which one this one fits. This one, 1 is not less than 1. 1 is not greater than 1, but this one has the equal sign, so that one can equal 1. So this is the equation I'm using down here. So it's going to be negative 1 plus 3, which comes out to be 2. Okay, so double check those with your answers, make sure that makes sense. And then we're going to try something new. We're going to actually go through and draw a graph of what that piecewise function looks like. So I'm going to erase this over here. Slide this graph over a little bit so we have a little more room. Okay, when you go to graph a piecewise function, they can be a little bit tricky, but here's some things that can help. You're going to graph each part of the equation in its proper place. within its proper boundaries. So what I mean by that is whenever x is less than 1, we're going to graph that. We're going to graph that y equals 2x plus 1. When x is greater than or equal to 1, then we're going to draw this graph over here. So the first thing you're always going to start with is with the boundary. So we're going to look at this. When x is less than 1, I do one equation. When x is greater than 1, I do a different equation. So when x equals 1, just draw a boundary. And then above each side, so I'm going to draw one graph on the left side, one graph on the right side. So when x is less than 1, so when it's like 0, -1, -2, we're going to be graphing y equals 2x plus 1, right, when x is less than 1. When x is greater than 1, that would be on the right side over here. I'm going to graph my second equation, which is y equals -x plus 3. You can graph these. These are both lines. And we've practiced a lot with graphing lines. You can graph them however you want. So you can use slope-intercept form. The other option is you can do a table. And a lot of times on these piecewise functions, I think a table is easier. So that's the way I'm going to do it. If you want to use the slope and the y-intercept, you can also do it that way. So I'm going to start over here on the left side, make a table. I'm going to plug in some values. Now when I plug them in, values for x, I have to plug numbers that are less than 1. So I could plug in like 0 and -1, -3, anything to the left of 1 I can plug in. So maybe I'll try like 0 and -2. So if I plug in 0, I would get 2 times 0 plus 1, which is 1. We actually did that right up here, right? We plugged in 0. If I plug in -2, I would get 2 times -2 plus 1. 2 times -2 is -4. -4 plus 1 is -3. So there's my 2 points. I've got 0, 1, and I've got -2, -3. And that's enough to draw our line. So we're drawing our line. Now when I draw this, you got to be careful. I can't cross my boundary, so that line has to stop right there on the boundary. All right, let's go ahead and graph this other one, y equals -x plus 3. So again, I'm just going to make a table. Again, when I'm picking numbers to the right of 1, bigger than 1. So any of those numbers. So I'm going to do like 2 and 5. So if I plug in 2, I get -2 plus 3, that's 1. If I plug in 5, I get -5 plus 3, that would be -2. So I got the point 2, 1, which is right there. I got the point 5, -2, which is right there. Oop, I put that 2, 1 in the wrong spot. Sorry, that's 2, 2. Let me try that again. So I got 2, 1, which is right there, and 5, -2, which is right there. That's better. Okay, so I'm going to draw the line that crosses through there. Okay, this is the last thing you have to know. So I'm almost done here. I've got my boundary. I've got my my graph on the left side and my graph on the right side of it. We have to decide on the boundary. One of the graphs is going to include the point on the boundary. The other one isn't. And it's really easy to tell. The one that has the equal sign, the one that can equal 1, is going to include that point. So that's the one over here. So what I'm going to do is I'm going to put a closed dot to show that that point is included. The one on the left side, this one up here, right? It does not have an equal sign. I always put an open dot right there. So on the boundary, you can't have them both be closed. So you have to look at it, decide is it open or closed when you do that. Okay, so that's evaluating piecewise functions and graphing piecewise functions. Let me do one more graph for you so you can see another example. And then I think we're good with the evaluating. We're going to skip by that one. That one's a little bit different. All right, let's try this one right here. So you want to graph y equals -x minus 4 if x is less than 0, and y equals x if x is greater than or equal to 0. Okay, so when we go to graph it, we always start by drawing our boundary. So this one changes. When x is less than 0, I graph this equation. When x is greater than 0, I graph this equation. But the most important thing first is that my boundary is at 0. So go right down the y-axis when x is 0 and draw our boundary down there. So on one side of that boundary, you'll graph one equation. On the other side, we'll graph the other one. So when x is less than 0, we're going to graph y equals -x minus 4. When x is greater than 0, we're going to graph y equals x. Those are my two equations. Okay, let's make our table. I got to pick some numbers to the left, or less than 0, so anything over here. So we could do like -1 and -3. If I plug in -1, this is a little bit tricky. It's y equals a -1 minus 4. Well, that changes to a plus, so 1 minus 4 is -3. If I plug in a -3, That would be a negative 3 minus 4. That would change to a plus. Add those together, we get negative 1. Let's put those 2 points on here, negative 1, negative 3, and negative 3, negative 1. So that line's going something like this. And I'm going to stop right there on my boundary. We can actually decide now if it's open or closed. That one does not have an equal sign, so we're going to do an open dot. Because it's just less than, it's not less than or equal to. Okay, now on the right side, I'm going to graph y equals x. So we're going to make a table. Again, plug in some numbers. Plug in 1, I get 1. That's a pretty easy one, right? If I plug in 2, I get 2. So here you got 1, 1, 2, 2. So it's going up that direction. When I get back to the boundary, decide if it's open or closed. That one has the equal sign, so we're going to do a closed dot. Okay? And that's what our graph looks like. So if you always draw the boundaries, write each equation above each part you're going to graph, and then it's just a matter of graphing lines. And again, tables work really nice for these. Let's actually do one more. Let's go back to that one I said was a little bit different. Let's try this one really quick. This is what we call a step function. And you'll see why in just a second. Okay, so we're not going to worry about evaluating it. We're just gonna graph it. So between 0 and 1, this is my equation. So I'm going to go first, my first boundary is between 0 and 1. And right above that, right here, my equation is y equals 1. Well, the way we graph y equals 1, if you remember, that's just a horizontal line. So I come to 1, it's just a horizontal line like that. And now I have to decide if the dots were open or closed. So if you notice, with 0, it's got an equal sign. So that's a closed dot. At 1, there's no equal sign, so it's an open dot. So it's an open dot right there. Okay, my next one is right here. It's between 1 and 2. So we're going between 1 and 2. Those are my boundaries. And between there, my equation is y equals 2. So I come up to 2, looks like that. Just a horizontal line. It has the equal sign with the 1, so that's a closed dot. It does not have an equal sign with the 2, so that's an open dot. Okay, between 2 and 3, draw a horizontal line. And again, at 2, it's got a closed dot. At 3, it's got an open dot. The next one's between 3 and 4. So it's equal to 4. It's got a closed dot with the 3 and an open dot with the 4. Okay. Hey, and those boundaries, you can leave them, but they're really not part of the graph. They're just to help us to graph it. So I'm going to erase them. You can kind of see what it looks like. So when I get done, my graph ends up looking like, kind of like some steps, right? Let's see if I can get that. Okay. So it ends up looking like some steps, and that's why this is referred to as a step function as you go up that direction. But again, if you take it and you just draw those boundaries and just focus on what does a graph look like between those, in that part, graph it in that part, and then just keep moving there. Hey, make sure you let me know if you have questions. Good luck with the assignment.